didn't see you sitting there. I'm MiracleMax and welcome to my YouTube channel. I've been thinking about a motto for a while now and I'd like to get your opinion if I can. I thought I could call it making complex things simple, or making the complex simple. Tell me what you think in the comments below. So what's this channel about? I'm glad you asked. But before I explain to you, I just chucked my coffee in the microwave. Nothing worse than a cold coffee. Alright, so firstly I thought what we'd do is we would
make some complex things into something simple. I'll do some automated things, I'll do some stuff for kids, little experiments. I could do electronic components, which I really love. I could do some building projects, which I really love. And I could turn them into all these complex issues, which are simple.
What do you think about that? Well, what's your opinion? What? It's cold? Why is it cold? Wait, microwaves, where have you gone? Stupid thing must be busted. I just had an idea. Check it out, even my ideas are energy efficient. How about I use this microwave repair as an example of what I intend doing for the channel? What do you think? Join me on this journey. We'll check it out. Psst, check this out. Just been up to the tip and picked this up. It's a twin of this one. Check it out. So I can use it for spare parts. Awesome. Kind of heavy. I'll get it up to the lab while my wife's not home. Kind of heavy, these things. It's okay, I'm fine. Don't panic. It's all good. Just walk it off, walk it off. I'll see you in the lab. Oi, you coming or what? Welcome to the real world. Well, actually, it's just my lab. And when I say lab, I mean like a table with a few bits of equipment in the background. But I like to call it home. Anywho, back to the story. You know, there's more than one way to skin a cat. You've probably heard that expression. And there's more than one way to test a microwave oven. How about you come outside with me and I'll show you one way that they always tell you not to test things, like putting metal into a microwave. But check this out, this is absolutely cool. See you outside. So what you do is you grab yourself a glass of water, or half a glass at least, a light bulb. You chuck that in the water. Just make sure that the metal section is covered by the water. That'll absorb any energy. You chuck it in the microwave, little offset on the plate there. You turn it on for 10 seconds should do it. Stand back and watch the show. And voila! Flash. Flash. Isn't that awesome? So why does it do that? You pull it out. You check it. Oh, it's warm. My light bulb is medium rare, just the way I like it. How cool was that? Awesome. You're probably wondering to yourself, who invented the microwave oven? I'm glad you asked. Let me explain. The guy's name was Percy Spencer. He worked for a company by the name of Raytheon and who was working with radars, etc. for defence during the Second World War. He noticed one day when he was walking past a radar, in his top pocket he had a chocolate bar and that melted. Ew! Nasty. What he decided to do was to try and see if he could melt other things, other food. And of course, first of all, he tried popcorn. And that became the world's first microwave oven popcorn. Secondly, he tried eggs, and in fact, it exploded in his co-workers' faces. Well, he wasn't deterred because later on, working for that particular company, Raytheon, they were able to patent the microwave oven. It was a little bit different to what we have today, but at the time they called it the radar range, and it was pretty impressive, apart from the fact that it was almost 2 meters high, weighed about 340 kilos and about $5,000. Hang on a sec. No, not this week. It's empty. Alright, so way out of my price range. But what else can we look at? How does a microwave work? I'll get back to you shortly. So a microwave oven is broken down into several main components. The first component, of course, is the big metal box. Now, it's designed to be metal so that all those electromagnetic waves can stay inside. Secondly, we have a transformer, an electrical transformer that provides the high voltage that's needed for the magnetron to operate. And of course, we also have a transfer port that takes those microwaves into our main box. What about the screen door? That's pretty weird, isn't it? It's not just a place so that you can sneak through and look at your food so it can't see you watching, is it? No, it's not. It's actually designed to be what's called a Faraday cage. A Faraday cage stops those electromagnetic fields coming back at you, which is a good thing in my opinion. So, what's so good about a microwave compared to a normal oven or cooking? Well, with a conventional type oven, what we experience is when heat is being transferred through our food, it starts at the outside, doesn't it? And that heat is then transferred onto the inside. That's why you find your steak is cooked on the outside, but sometimes it's rare on the inside. I like it that way myself, actually. But a microwave, however, is different. It works on electromagnetic waves, and those waves go backwards and forwards, hence the term microwave. And as those waves go backwards and forwards, it actually cooks the outside and the inside at the same time. Hence, it only takes a short period of time. But how does it do it? I'm glad you asked. What it does is it actually agitates the water molecules that are in our food. And as those molecules try and line up with the waves, what it does is create friction. What do we know about friction? Friction creates heat. What do we know about heat? Heat cooks our spud, doesn't it? Excellent. So, now we know a little bit about the operation and history of our microwave oven. Let's see if we can fix the thing, okay? We're just about to do some testing with some high voltage. Now, not only are we looking at the 240 volts that comes out of the wall, but we're also looking at voltages that go past the transformer or come out of the transformer secondary, and that's about 1.5 kV or 1500 volts. So what I use is an isolation transformer shown here, and that helps isolate me from the house so that it gives me more protection. But if you're not competent with doing electrical stuff, get someone else to help you, or just gain some knowledge before you attempt anything, but please be safe. Just another safety caution to mention to you is that when we're working particularly on high voltage areas like in this transformer area, in our power supply area, etc., generally speaking you will find a capacitor, a large capacitor, similar to something like this. That's an electrolytic capacitor, and what you need to do, because this holds charge and you can get quite a shock from them if you don't discharge them before you start working on it, after you've turned the power off. So what I've made up myself is just a plastic pair of tweezers, and I have a couple of little resistors in here that are joined together, joined in series there, and I simply put that across the terminals on my capacitor there to drain them off. If you haven't got anything like that, you can also use just a lamp, like a 240 lamp that I've made up a couple of terminals, and you simply put the terminals there, and that will discharge any of the capacitance that's held in there. So then you're safe to work on the component, or the microwave in this case. So the main components of our microwave oven include the input section of the 240 volts that come out from our wall. We have a fan back here, and notice I'm using what's called a spudger, or a piece of plastic, to point to you because I'm being safe. Our fan operates here off this little electric motor. We have the power supply, the voltage that comes up, and it goes up to our front display section there. Has another little transformer in here, and it also comes down to our transformer here. Our main transformer is just there in this boxed area here. As it says, danger, high voltage. as I mentioned already, be aware that we're looking at about 1500 volts coming out of this thing, out of these two red wires into our magnetron. So it's extremely dangerous. It can also damage your equipment as well, so just be aware of that. In fact, I have a very sad story to tell you. When I was testing, I actually blew up one of my haloed multimeters. Very, very sad occasion. I was devastated for days, but fortunately I was able to race out and buy another one, much to my wife's chagrin, but never mind. So yeah, just be aware that you can blow stuff up. Alrighty, so what I've done at the moment is I'm just checking for, I've already checked for power here at our input. I know I've got power. The fan rotates, so I'm happy with that. And what I'm checking now is power going into the transformer. So it should be about 240 volts because that's what we have here in Australia. But I won't measure the voltage coming out into my magnetron because that's the 1500 volts. My multimeter will not handle that. So what I'll do now is I'll just turn on the microwave and just notice the fan when that rotates, and I'll show you the voltage that we have coming through. Okay, so you can see the fan rotating there, and we've got about 250 volts there, so that's a good indication that it's working. In theory, you shouldn't really run the microwave without anything inside of it, so that's something to be aware of. Okay, so that's broken it down for me. I know that I'm getting my voltage coming into the magnetron. I know that for a fact because I've got power coming in here. I won't test it here as I said, but I feel pretty confident that the magnetron may be faulty. So what I'll do next is pull that apart and have a look at it. Before we go any further with our testing, we need to check the transformer. Now the transformer, as you can see, is that little, is that little fella in there. That's the copper wound transformer. It has two sections to it. It has the primary, which are these, the blue and the brown wire here, and then if we come around the other side of it, these two red wires coming off is the secondary side of things. That's the high voltage side, or the higher voltage side of things. So how do we check a transformer? Let's firstly find out how a transformer works. So to understand how a transformer works, we really need to understand magnetism. Remember back at school we had magnetic bars, and of course we put down iron filings and we saw how that worked. So of course we had one end north, the other end south, and then we had that magnetic field radiating from one side to the other side. And in actual fact it came from north to south. And that helps us to understand how a transformer works. That works on a magnetic field as well. So to get a proper understanding of how a transformer works, and now that we understand how a magnetic field works, what we'll do is create an electromagnet. So we start with a soft iron core, which is basically laminated iron. Next we'll put on a primary winding, which is just a few turns, and that goes around there, just a few turns, and that's on one side of the transformer. So that's called the primary side. On this, what's called the secondary side, we have quite a few more turns of wire there, and that in turn will be our secondary. So what happens at this point is that our primary puts in AC voltage about 240 volts, and as the magnetic field expands, it creates what's called mutual induction into the secondary side of things. In this case it creates about 1500 volts. So that's how a transformer works in basic terms. We have on one side very few turns, and on the other side we have a lot more winding, which in turn gives us our 1500 volts. testing purposes, what we would do is turn it to ohms. We can see that there, and we would check across this wire and this wire to see if we had continuity, and then on the secondary, because it's a single wire, we check there, and that will tell us if we have continuity or not. I've just removed the cover off the transformer area, but unfortunately, as we just note down here, it's written on the side there, it says inverter. Now this style here, an inverter, not only includes the transformer itself, but and of course the primary is over here, as mentioned before, and the secondary is over here. But also the power supply is in that section. So we have the filter capacitors, the main filter capacitors, as I mentioned before, they're the ones that you drain. But also we have the switching side of things that turns it off and on. So it's not quite as easy as just checking with an ohm meter across the resistance here and over here on the primary, the secondary here being of course. It's not quite that simple, but there is another method that I'll show you that I can be certain that the transformer is actually working. Another way to test for transformer output is using an oscilloscope. Now I happen to be fortunate enough to have one or two of them, and what you do is you remove the actual earth connector of your pickup, so you don't use it at earth at all. You're not trying to touch anything, simply pick up the inductance of the transformer output at this particular stage. So we'll just turn it on now and see what it does. Where are we? 10 seconds, start. Alright, so as you can see, the oscilloscope is showing an AC output as I get it close to the transformer. So that indicates that the transformer is working okay. When I'm working on electrical components, I like to make sure that I always have, just to be safe, I always make sure that I have the power plug in front of me so that I can see it. So there's no chance that I've accidentally left it in the wall or anything, so I leave this right in front of me so that I can see it. What we'll do now is we'll pull off the Magnetron here and we'll check it out and see what it's like. Before I go any further, I'll just check for the resistance and make sure that there's continuity, or in other words that the wire is not broken. So I'll just do that there, which it's good, it's got good continuity there. So the wire's not broken at all, or the element I guess you could say. And also what I'll check and make sure that it's not shorted straight to ground. So if I just put that onto there, I'm actually on one of the element that comes in and onto ground there, and that'll tell me if it's got a dead short or not, which, as long as that doesn't fall through there, yeah, it's always the way. Okay, so I've got no reading there whatsoever, so I know it's not shorted to earth as well. So in that sense, the element side of things, or the electrical side of things, is working okay. But why is the magnetron appearing to play up? So we'll go further. Oh. Okay, so that there is your magnetron. Nothing special. In fact, I reckon I can see what's wrong with it straight away. It's got a broken magnet. Notice that there? I don't know if you can see it. See the line down there? It's actually got a broken magnet, and that will cause the magnetron not to operate correctly. They've got two ring magnets, one up the top, one up the bottom, and they're crucial to make the magnetron operate correctly. So I'll pull it apart and see what I can find. Okay, so here's our culprit. I've pulled apart the magnetron, and as I mentioned, there's two big circular magnets in there, and this one is clearly broken, as you can see, broken in two, and of course that upsets the magnetic field required within the magnetron to direct the electrons into the magnetic wave. So there's our problem. So I'll stick in another Magnetron and see if I can get the thing up and running. I've checked the Magnetron in the microwave that I picked up at the tip, and that's actually in good condition. So I've been able to trade it out and put that into our microwave here. So fingers crossed it's going to work okay. The magnets looked alright, and I did a check on the element and that seemed fine as well. So I'll just pop it back together and let you have a look and see if it cooks something. I've still got the outer shell off it at the moment, but I'll just give it a burl and see if we can actually fire it up. Everything looks safe in the back there, I think. Yes, that looks all okay. I'll just stick it on for, I don't know, 30 seconds and see what happens. Okay, she's hot alright. Don't know if you can see the steam coming off it or not, but it's certainly warm. You can see the condensation starting to build up as well. So I'd say that's a fix, that's a good thing, so I can put it back together, stick it back where it belongs and make my wife happy. Well, I hope you enjoyed watching this video as much as I did making it. Watch out in the future for more electronic repairs and experiments, and automotive repairs and experiments and other things as well as they come to mind. I also will have a section called Kids Corner. That's where I'll be doing electric experiments with kids, and I encourage parents to watch it and do it with their own children as well. So if you did enjoy the video, please give it a thumbs up, share it with your friends, and I look forward to seeing you next time. See you guys.